Hello, everyone. This is SIG scheduling meeting on February 25th. Let me try to share the agenda. Okay, I think you can you see the
Yes.
screen?
Yes, Dom.
Okay, that's great. Maybe let's make it a little bit bigger. Are there any topics that we should add to the agenda? Okay, I don't hear anything. So do we have Zil, the owner of the first one?
Yes.
Hi.
Let me share my screen.
Dominic, quick question before that. How much time do we have allocated for this particular topic?
I don't know.
Okay,
Zil,
it's free
what
form.
do you think?
That's
How
good.
much
I mean,
time?
it's not limited. Perfect.
So
Can you
yeah.
allow me to share my screen, please?
Okay, let me try to find the settings.
Okay, now I think I have the permission now.
Okay.
Can you all see the screen?
Yes.
So I'm Zeel and I will be presenting GPU aware scheduling as part of Gaurav Kumar and Amit Kumar. We all work at Uber. So we are part of the batch compute team at Uber. So as part of so the compute team at Uber manages batch and stateless workloads to and as part of our job we get the bare metal host and the services run as infra as service and as part of batch we run ray clusters spark job and compute batch jobs in our bare metal host and we run kubelet on those hosts. So uh, all our workloads use GPUs and we utilize GPUs for ML related bad jobs like rider pricing intelligence. We do ETA estimations, we do destination suggestions, etc. Requires GPUs to train the ML models. Uh, this is the infrastructure of the compute team at Uber, which I explained in the previous slide. So, summary or motivation that we are planning to present in this meeting is that we want, in one line, we want a filter plugin which blocks pods which are not requesting GPUs to be scheduled on nodes which has GPUs. Why? Because it is very common terminology or common practice to have hybrid Kubernetes clusters, which where kubelets can be GPU. Basically, they can have GPUs along with CPU, memory, and disk, and there can be kubelets in the same cluster which does not have GPUs. Since pods which does not request any GPU can also get scheduled on GPU nodes because that pod will eventually be requesting CPU, memory, or disk, or all, and all those can be satisfied in a GPU node as well. So that pod can get scheduled on a GPU node. But the issue that we face in such scenario is that such pods takes up the remaining resources, takes up the CPU, memory, and disk of the GPU node. And later on, when an pod which needs GPU comes up, uh, ends up waiting for a long period of time till that CPU, till that non-GPU pod is running. So
Just to add to that here, so in our practice, when we run such workloads at Uber, what we have seen is that it's always advantageous to only run GPU workloads on GPU nodes. Because in practice, we've rarely seen that the GPU nodes are sort of running underutilized, especially with all the AI and other machine learning use cases. It's rare that we have underutilized GPU nodes as opposed to underutilized CPU nodes. Please, Zeel, go ahead.
Mm-hmm.
yes, so the filter plugin will do exactly what we're proposing. It will block the non-GPU pod to get scheduled on a GPU node. This issue, so we propose this as a plugin in the scheduler plugins repo, but the question that came is why taints and tolerations cannot work for this use case, is because at Uber, we get the bare metal host, and we, as part of compute team, manage the entire Kubernetes infra. The customers or the users of those Kubernetes host, such as Recluster or Batch job or Spark job, are part of a different team. So they will have to, they basically, they are unaware of the taints and tolerations that exist on a Kubernetes infrastructure. So as part of compute, it's our responsibility to ensure that the workloads which is requesting GPUs, basically customers will directly send the pod with the GPU, non-zero GPU request in the spec, but they cannot add taints or toleration on their side. So it will be later on our responsibility to ensure that the scheduling happens such a way that GPUs are not underutilized.
Mm-hmm. So can I ask a question here? So is it possible? So I understand that the same problem applies to labels and the affinity to those labels. Is that correct?
Yes.
Mm-hmm. So basically the problem that I see is that the Kubernetes evolves in a way that pods needs to specify what exactly they need. So there is this whole DRA, dynamic resource allocation program, which introduces even more complex terms like resource claims, in which pods need to specify which exactly resources they need to allocate. So everything that scheduling does is to try to fulfill those needs, but those needs has to be expressed somehow. So I wonder if it's possible for you to somehow manage those users configurations and have those necessary elements injected to.
Yeah, so Dominic, thanks for that insight. Um, so in Uber or any multi-team organizations, customers are sending their request with what they need. They are saying that we need these many cores, this much memory, and this much disk. That is coming as part of the spec of the pod. After that, is, I mean, they don't care. most of the time they don't care on which node or which cluster these pods are going to run because we are running them on shared clusters to achieve efficiency across multiple teams. One option was that every customer could have created their own cluster and they could run their way, and they have full freedom. They want to manage the cluster their way. But we opted for the solutions in which single central team is managing all the clusters and adding some federation on top of that as well. And so that it's invisible to customers. For them, it's one virtual Kubernetes cluster basically. And they are providing what they need. Now, after that, how efficiently we can run these pods with the whole resource efficiency, whether we run this pod on GPU node or whether we run this pod on CPU node, and given that GPU nodes are limited in number, once the new GPU node comes, how much time they will have to wait, all these problems a central team has to solve, because it's possible that the CPU workload was coming from one team and the GPU workload was coming from other team. So their request is that why do I have to add extra configurations, extra parameters if I am giving you what I need? Now it's your responsibility. By your, I mean the admin team or the cluster team's responsibility to run it efficiently. That's a problem we face in this setup, and that's what stopped us actually from using any solution that depends on fully on the customer, because A, it will be a problem for them. B, they can abuse it also. It's possible that some of them are unnecessarily setting it. That's a possibility. And then we have to add then later set of checks in the administration controls and multiple places that, okay, these workloads are not good, they should be rejected, etc., etc. So to avoid all those things, we fell back to this problem, this solution that, okay, they should set what they're normally supposed to set. After that, it will be our responsibility how we manage them correctly.
So have you considered Q as a workload management system that handles the problem on a little bit higher level?
Yes, we did talk to Aldo and Abdullah earlier for KQ, right? You're talking about, I guess. And we had a plan for convergence, because other than this, there were so many other requirements which we had. Like we have very advanced resource management and quota management systems, which we wanted to include with KQ. And it was not aligning like perfectly. KQ will take its own time with the set of requirements we have. So in future, we do want to keep that route open. We do want to merge our resource management systems with KQ, but I cannot see any short-term or very limited time frame in which it will be possible from Uber perspective also, and from in general open source perspective. So yes, we will keep that channel open to talk to them for sure.
Okay, another question. So do you want to have such a in-tree plugin, or are you okay with having the plugin elsewhere and simply build your own scheduler?
That's a very good question. This discussion happened earlier also on the GitHub actually. So our North Star is that we would like to be part of the default Kubernetes upstream system. So this should come as with the native set of plugins, which which can be turned off and turned on. But to start with, we are okay if this is merged with just the plugins repo and people can use it. If we find it that this is useful for many people and we are getting upwards there, then we can consider adding this to the default set of plugins in Kubernetes. Otherwise, we can keep it in the plugins repo also. Whoever would like it will use it. Whoever doesn't like, it's okay. They don't have to use it in that case. So we are open to both the options basically.
Okay.
I am wondering of one thing, like if it's a problem between the user sending the pod spec and the cluster, couldn't you use the mutation admission webhooks to modify the pod spec to apply the tines on it?
Yeah, so in general, another point is that we avoid mutating customers' request unnecessarily, especially in the spec. If it's from like some metadata perspective, that might be a choice, but normally in the spec, we avoid doing this in general. So there's a there's a concept of state management also. Think about this. Customer is integrated in two ways. They are submitting the request, which is a client, which is submitting the request. And then after that, there's an operator, which is acting on this request actually. Because these are batch workloads like a Spark application or Ray workload. All of these are custom resources. And there are certainly an operator, which is understanding these custom resources and converting them to pods. So if customer has some understanding between the client layer and the operator layer, and if we modify the request in the middle, that will not be good actually. It can create problems for the customer side.
Okay.
So how the customer says that they need to use GPU or what type of GPU? Is there any spec they have to provide?
Azil, would you like to answer that? Do you have details?
Yeah, so we expose
Or Gaurav, who
GPU.
wants to? Yeah.
So
Sure.
Go ahead, Zane.
yeah, GPUs on the node are exposed via the NVIDIA daemon set pods. So requesting GPUs will in a pod spec will be similar to any other resource like CPU or memory. So in the pod spec under resources, either request or limit, just the way we add CPU, we can add NVIDIA GPU.
It's
So
coming
that's
at
how.
extended resource, right? It's important to emphasize that.
Extended
Yes.
resources. Mhm.
Yes.
Right, but user has to specify it, right?
Yes.
That's correct.
Okay. Okay, I think you can go ahead with the presentation.
So this is what we are proposing. If it's a GPU pod, the pod it's requesting GPUs, it should only get scheduled. It will of course be get scheduled on a GPU node because of the native scheduler ensuring it satisfies all the resources, but the filter plugin will avoid a pod which is not requesting GPUs from getting scheduled on uh, any kind of GPU node. It will ensure that the pod is scheduled on a GPU node itself. So filter plugin comes. So in scheduling, if we want to add a filter plugin, we add pre-filter stage and filter stage. Uh, Pre-filter stage basically gets the pod related information and store it in a cycle state, so that filter stage can use it, and we don't have to do the same calculation for every node for a one pod. So in the pre-filter stage, what we'll do is we'll check the pod's resource request and limit, and if that has non-zero NVIDIA or any kind of GPU that the Kubernetes infrastructure supports, if that has non-zero GPU request, that pod will be marked as GPU pod, and that information will be stored in the scheduler cycle state, and that cycle state information will then be used by filter state for every node for a particular pod. It will check that if pod is not requesting GPUs, and if particular node is GPU node, that filter plugin will mark that pod to be unschedulable on the GPU node. And for the rest of the casings, the scheduling will work just fine. It will be marked as schedulable. So, given a pod spec in the pre-filter state will store whether the pod is requesting GPUs or not. And if it is not requesting GPUs, in the filter state will check for every node, will check um, whether it's a GPU node or not. If it's a GPU node, that particular pod will not be scheduled on that, but the filter plugin will not allow for that pod to get scheduled on that particular node. For the rest of the cases, it will be marked as schedulable. So only this path will be affected. Rest will work just as fine.
Mm-hmm.
There is a special case which needs to be handled. So in our case, or in any other case, GPUs are advertised using device plugin pods on the nodes. And at Uber, we use the NVIDIA device plugin. And with the help of daemon set, we expose GPU related information on the node. But whenever there is a device plugin upgrade, whenever we want to upgrade any kind of, whenever we want to do any kind of change on the device plugin pod, uh, that pod basically eventually get restarted, right? So and that particular pod uh, itself does not request any GPUs, but because it exposes the GPU information from the host, ideally it should run on the host which has GPUs, bare metal host which has GPUs. But because it is not requesting any GPUs, our filter plugin will not allow such pods to run on the GPU node. So this problem will specifically happen whenever there is a restart. So node will of course be a GPU node, but pod is not requesting GPU. So the device plugin pod will not be allowed to run on the GPU node. So what we'll do is the device plugin, whichever device plugin which is being used, if the pod spec has the image of that device plugin, basically container image of the pod is of device plugin, will mark the pod as GPU pod in our pre-filter state. So the pod will be allowed to run on the GPU node.
Yeah, so
So
as a summary here, like in our infrastructure, the only non-GPU pod that sort of runs on a GPU node is the NVIDIA device plugin pod, which is kind of necessary. In the plugin implementation, we have tried to make this configurable, so you can specify like a list of pods which you want to run on your GPU nodes, and then those will be excluded. Yeah, go ahead, Z.
yeah, that's it. That's it for the slide. So this is the filter plugin that we're proposing. As Amit said, we can start with the plugins repo. If things look good, we would like to merge it with the default scheduler plugin.
Mhm. So are you okay with leaving the pods that don't use GPU unschedulable if only GPU nodes are available?
Yes.
Sorry, what's the
So
question?
So if a pod is not requesting GPU, but there are only GPU nodes available,
Mm-hmm.
so are you okay with leaving that pod unschedulable?
Yeah, we are okay with that because we have resource management layer also, which is seeing that okay, which is fair, basically fair expectation from customer that if they're not requesting any GPU and they are and we don't have any other CPU node basically available, all the resources are consumed and cluster is running hot, then their pods can go for waiting and unschedulable. That's perfectly fine for the customers because they're
Mhm.
not paying for it that point of time.
Okay, so have you considered also like implementing it in scoring phase so that you avoid scheduling on the GPU nodes but still accept it if there is shortage in other type of nodes?
That's as we explained earlier. Mm, we never, so point is that we never want to schedule the non-GPU pod on a GPU node because we don't have any schedule of when a actual deserving GPU pod can arrive. And we don't want to keep that one waiting. So we want to completely reserve these nodes for those pods whenever they arrive. And as Gaurav explained earlier also, most of the times our cluster is running hot, which means that most of the times those GPU pods are actually running. And if we schedule any pod which doesn't require GPU and which goes to GPU node and the other GPU workload goes to pending, that is a problem certainly because it's A, wastage of money, and B, those teams are very high critical priority jobs. So we normally don't want to do that.
Mhm.
We did not consider the recovery part. Yeah, go ahead, Gaurav.
Yeah, as I mentioned, like if GPUs are sort of sitting underutilized, like the idea is to just like scale down and return those GPUs, especially in cloud, right? Because GPUs tend to be more expensive than CPU resources. So it's very rare in practice that we see GPU nodes being underutilized than the other way around.
Okay. So I think we can definitely continue discussion offline, because not everyone was joining this call, and I think there are many community members that are very experienced and active, so they may have some other suggestions. Although one thing I wanted to think about is that we are currently looking into a possibility of introducing resource reservations in Kubernetes. This is very early discussions, but the concept would basically allow devoting some nodes to a specific reservation, and to make a pod running in that reservation, it would have to simply link to that reservation. So the pod would have to specify which reservation it belongs to. So in fact, it would work a little bit similar to Taints. But so I'm not sure if this is something that could help you. But if you were able to specify a reservation in a pod that requires GPU, then maybe it would help. But from what I hear, the problem would be pretty similar.
But
Yes, yes.
DRA work has still not started yet, right? So,
Yeah, implementation wise, no, it haven't.
yeah, so till then there should be some solution.
And also, we don't know how that solution will shape. I mean, it will depend on. So, in case it's resource management and resource reservations, please include. I mean, please tell us. We will also like to get included in that discussion, because we have very advanced layer of resource management working, starting from Pelton world to now in Kubernetes world also. And we have presented this in the KubeCon also earlier in 2023. So, yes, we would like to contribute if we can do something there. Um, so, but I would like to keep this particular discussion decoupled. I agree with your proposal of doing more discussion offline. That's perfectly fine. There's a GitHub uh, KP open. Zil, please share with Dominic. He can also take a look and he can comment. Uh, and it's already shared. People are giving their comments. So from there, we got a suggestion that we should present it to SIG scheduling meeting first to get the feedback. Now we have presented it here also. So we are sharing the GitHub link to you. Please provide your feedback there, and then we can take the discussion forward.
Mm-hmm. Okay, I think that sounds good. You know, you should be aware that there are probably more teams facing similar problems. I know that most of them are solving the problem with taints, so that's so your requirements are a little bit at the
And
edge currently.
another is because the cube batch compute at Kubernetes is not as much adopted as the microservices compute uh, at Kubernetes. So finding such examples in bigger companies, they might be in their early stages of running batch compute in Kubernetes. Uber is certainly one of the early movers for running batch compute in Kubernetes, because we wanted to have a common scheduler for all types of compute. be it microservices or batch compute or anything. In fact, now we are planning to do the stateful compute also on Kubernetes, and for that work has started. So that's why we want to, given that this is a kind of early work, which we want to make this option available. We are not asking anyone that you have to use it. At least make this option available so that they can consider this if they find it useful.
Right. Okay, so you have to include the plugin to make that functionality
Yes.
there. Okay, well, I think from my point of view, it sounds reasonable. But yeah, let's give a chance for others to comment.
Azil, can you please share? I mean, Dominic, how do you want this? On Zoom chat is fine, or you want email for this link?
I think it's best to put into our notes.
It's
So
already there, I guess.
Yeah, it's already present.
it's this one, right?
Yes.
We cannot see your screen.
Yeah. This one, right?
Yes, yes, Dominic.
Okay, so I think that's all, I guess. Regarding our items, I think we need to postpone it to the next meeting because Kazai was not able to join, so there are no too many people from the community on today's meeting. So
Okay.
I think we can conclude with it.
Thank you.
Okay.
All right.
So
Thank you,
thank you,
everyone.
guys.
Bye-bye.
Thank you.
Bye.